Hello folks, let's come back with this last problem of this exercise, problem number 23. Let's see what do we do about it. So it's like the moment we see 1 over x times x squared plus 1, it should not, you can do it, but that will be lengthy. You can take a over x plus bx plus c over x squared plus 1 and do it, but that will be a little more lengthier. You could be a little more tactful by multiplying x here and x here. I have told you that whenever you have an integral which is of the type x times x raised to n plus or minus 1, it's always better that you multiply x raised to n minus 1 both in the numerator and denominator. That works fine. So that substitution should be, that kind of work should be better here. So we will have this as integral by multiplying x both in the numerator and denominator. We can have this as x squared times x squared plus 1. With this in mind, because there is an x here, let's go in for a substitution u as x squared. So your du becomes 2x dx. So the x dx du over 2 becomes x dx. So you can have x dx substituted as du over 2. So you have your integral x dx becoming du over 2. And here you have x of course becomes u and u plus 1. Now this is very easy for us because you know that u times u plus 1 we can always substitute as, so let's consider 1 over u times u plus 1 as a over u plus b over u plus 1, which makes it as a times u plus 1 plus b times u, and u times u plus 1 over u times u plus 1 can cancel each other. You have a times u plus 1 plus b times u as 1. We go in for substitution so that you can get the values of a and b. First substitution of u as negative 1, so this vanishes. You get negative b as 1, b as negative 1. So that's over. Then you can substitute u as 0. If u is 0, then this will vanish and you will have a times 1 as 1, which makes a value as 1. You can go in for the integral from here. So your I is going to be half outside integral. This is a for us is 1 over u and b is negative 1 over u plus 1 du. So when we have this integral, it's perfectly easy. This is going to be integral of log u and this is going to be integral of log u plus 1 plus c. Or when we revert back, it is log modulus x squared and maybe x squared plus 1 plus c. Further simplification, because this is x squared, you could have it as it's better we see the option so that we know how much to simplify. You need a log x. You don't need it in quotient form at all. Not like the previous question where we needed the quotient form. So we don't need the quotient form at all. So I think it's wise to do away with this step. And let's not have this step. And let's have it like this. Half log modulus u minus half log modulus u plus 1 plus c. Reverting back, half log modulus x squared minus half log modulus x squared plus 1 plus c. You know that the exponent always multiplies. Log a raised to m is m log a. So like that it is going to be log, because that will get, this 2 will get multiplied here. So therefore, or maybe once if I want, I will show you, times 2 log modulus x minus half log modulus x squared plus 1 plus c. That's all. That's all for this. And when we look at the option, it should be the option A. This is option A.